Okay, so we're going to look at families of polynomial functions. So first one, y equals ax cubed, so that's just a cubic that goes through 0. It kind of does this sort of shape, doesn't it? Goes through 0. This one here, that's where it gives us the point of inflection, doesn't it? So this is our left and right bit and our up and down bit. My favorite one, so this is where it tells us all the three intersect. So it tells us that it crosses at 2, -5, and 4. And this is the one where it's in polynomial form. All these A, B, C, H, and K are called parameters, so don't forget that. Let's look at an example. So this one here, we know that it's the point 3, 10. So when x equals 3, y equals 10, substitute in our values, solve, and we get a equals 8. Easy. Second one there, we know that it's the point 5, 16. So again, we just subbed in 5 and 16. Work out our value of a. Our a ends up being 4/7. Now here, we're told the form of the function. We're told the form of the function. We won't always be told the form of the function. Here, we're told the form of the function. Two unknowns, 2 points, simultaneous equations, should be no problem. So that's the one where it's 1 and 16. That's the one where it's 2 and 30. So we can see when we work out this one that we've got 8a there, 1a there, 2b there, 1b there. So we can't do any elimination. So I'm just going to multiply this one by 2. And I get 32, 2a, 2b. So now I can eliminate the b's. I can take away and eliminate the b's. So if I do 30, take away 32, 8, take away 2, solve it, a is a third. If I then substitute into that first one, so that's the easiest one, I get b to be 49/3. So there's my solutions to a and b. Don't forget you can use your calculator if you need to, if you're allowed to. If it's the calculator one, much quicker, save you a lot of time. So we don't know the form of these, but it's not told us the form, so we've got to work out what form those are in. We can see that one there, we've got a double intercept there, so it just touches, and another intercept there, kind of in intercept form. We know the point 32, so we've had to work out what that rule was, put 32 into the equation, we get a to be a half, there's our equation. This one here, it's kind of in point of inflection form, isn't it? So this one here is in the form a x plus 1, so it goes through, there's the point -1, 2, so when it's in inflection form, that becomes a +1, +2. So turning point, point of inflection form. So maybe just to help with the algebra a little bit, take that 2 over to the other side, substitute in the point here. So this is the point that we've got, 1 minus 2, substitute those values in. We get a to be -1/2. So the equation is -1/2 there. There's our equation. Some notes for you. Quartic. So x to the power of 4. So you can see if that was a 3, that would just be the form for a cubic. So quartic, kind of, I reckon they look like flat-bottomed quadratics. So that one there, 3x to the 4, slightly narrower than that one. This one here, -1/2, so it's upside down because it's a minus. The half makes it slightly fatter. All right, so if we look at Desmos, we can see here that a is 1, h is 0, k is 0. So that's just y equals x to the power of 4. So let's run that one. It gets thinner, goes negative, comes positive again. So if I put that one back to 1, we can now run our h. Maybe we can run our h, move that out of the way. We can run our h. There you go. We can see our h is just moving it left and right. Let's try and stop h at 0. Not too bad. Run our k. That will make it go up and down. And now, just for a laugh, let's see what happens if we run all 3 of them at the same time. Okay. all sorts of stuff. Can't see anything at the moment. Is it going to reappear? There it is. It's appearing over there. It's going all over the place. So this is what can happen with your values of A, etc. Okay. All right, let's go back to the PowerPoint. Leave that site. Okay, so gets the graph of that function. So it's going to go to the right 2, down 1. Ending point 2, minus 1. So work out what my x-intercept's in. So I put y equal to 0, do a bit of algebra. I end up with 3 and 1. Got to work out what my x-intercept, y-intercept is. So put x equal to 0. That's usually the easy one. Ends up being 15. So there's my graph. We know it goes through 3 and 1. And it crosses here at 15. So there's the graph. To draw it on Desmos, that's what the original one looks like. So that's y equals x to the power of 4. That's what y minus 2 all squared minus 1 looks like. Okay, so let's have a look, see what this one looks like. So it crosses at minus 2 from that one. Crosses there at about 3/2. So that's my, sorry, that one there. Sorry, that one there's 2/3, isn't it? So this one here is 2/3. This one here is 1.5, 3/2. And this one here is at, that one there's at 1. So in that one there, that's the 1.5 one. So you can kind of see that this kind of looks a bit like a W shape, yeah? Because if my x values are all positive, then it kind of looks like a W shape. This one here, so it touches there at 3. So it touches. Okay, so this one here, still got a squared. Another one makes it a cubic. Another one makes it to the power of the 4. Crosses at 2. Crosses at minus 2 there. Okay, so this one crosses at 5, minus 5. That one there crosses at plus 3 and just touches it at plus 3 because that's a squared one. And then this one here is this one here, which will be minus 5/2. Next one, I can see that one's got a negative, so this one looks more like an M shape. Both of them are double ones. That one crosses at 4. That one crosses at minus 4. So we change the sign. Yep, that one crosses at 5. Another one there. So this one here crosses at minus 2, and it just has a point of inflection at 2. So that one there, point of inflection. That one there is where it crosses. And again, it's positive, so it kind of looks like a W. M is minus, so if it's a minus, it looks more like an M shape. Otherwise, it looks more like a W shape. Odd and even polynomials, so these are just stuff you've got to remember, so make sure you write these down. A function is even if f of minus x equals f of x, and it's odd if f of minus x equals minus f of x. Okay, so these two bits here are the same. These ones are different. So even, positive, odd, negative. So here's some even ones. So obviously 2 and 4. Here's some odd ones, 3 and 5. Can have a look at some Desmos for this. Okay, so let's have a look at this. Let's have a look if n is an even number. 2. There you go. We get this. It goes to an odd number. 3. Looks like this. 4. Looks like this, etc. So you can have a play around with that. You can get this PowerPoint on Google Classroom, and you can run it yourself. So there you go. It's just sort of changing from positive to negative, positive to negative, positive to negative, all the way there. So odd and even, odd and even, odd and even. There's some notes for you, and there's a couple of exercises, H and I. Thank you.